I'm Anil Kumar, sharing with you a variety of videos on rate of change. So in this playlist, you will find all videos which you should watch to understand this unit on calculus. The question here is, a man on a dock is pulling in a rope which is fastened to a bow of a small boat. If the man's hand are 12 meters higher than the point where the rope is attached to the boat, and if he is retrieving the boat at a rate of 3 meters per second, how fast is the boat approaching the dock when there is still 20 meters of rope out? The wordings are very complicated. So you need to read the question a couple of times to really understand what we have to do, right? So go through it and we'll actually make a sketch here to help us figure out this situation. Let's say that's the level of the sea, boat, whatever. A man on a dock is pulling in a rope which is fastened to a bow of a boat. If the man's hand is 12 meters higher than the point where the rope is attached, so what we will do here is we'll say that this is 12 meters higher and that is the boat, right? So attached to the boat. Doesn't make sense to you. So this is 12 meters for us and that's the boat. If man's hand is 12 meters higher than the point where the rope is attached to the boat, and if he is retrieving the boat at a rate of 3 meters per second, so that means this direction is at the rate of 3 meters per second. Okay. How fast is the boat approaching the dock? Let's say now this is the boat, right? Let's call this point B. How fast is this boat approaching the dock? That means a horizontal distance. Okay. When there is still 20 meters of rope left, when this distance is 20 meters, when this is 20 meters. So that is your final condition. You get the idea now. Okay, so I think we have understood. So let's define our variables. So it's good to define the variables as x for horizontal, y for vertical, and s for the rope. I could use r actually. Okay, and now I've written s. So let me use s. Normally we do separation for s. Okay, so that is the kind of situation we have. Now, in this y is fixed, which is always 12. How do we relate these things? So clearly, x square plus y square is equal to s square, right? So you could write s square equals to x square plus y square. Perfect. Now if I differentiate this with respect to time, what do I get? So I get 2s ds dt plus 2x dx dt plus 2y dy dt. Right. Now my y is actually fixed. I should have written 12 here, right? I should have written 12. So since y is equals to 12, we know dy dt is equals to 0. Does make sense to you? Since y is fixed, right? So dy dt is 0. So this term is 0. I could have written 12 here, right? Now, let us also see the final situation. We can actually simplify this. We are very close to that. And then we can write this as, let me complete this part. S times ds dt equals to x times dx dt. And that is 0, right? So let me write 0 here to be very clear, since y was constant. So what do we have to find is, how fast is the boat approaching? So we have to find dx dt. So this is what we need to figure out. We know ds dt. So in this case, ds dt is 3. Because the man is moving or retrieving at this speed, right? So ds dt is given to us as 3. So it's retrieving the boat at the rate of 3 meters per second. So we know this. We have to find when still there is 20 meters of rope. So when this is 20 and that is 12, what is x? That is what we should figure out, correct? Let's figure that out. So we know that x should be equals to, rather let's start with x square, should be equals to s square minus 12 square, right? So x is equals to square root of s is 20, so we say 20 square minus 12 square root. So let's calculate this value. So we are doing square root of 20 square, take away 12 square, equals to 16. So we know x is 16, we know s, the separation is 20, we know dx dt, we have to find dx dt. So now it's very simple, correct? So let's replace all these values. So s is 20 for us, so we know s equals to 20, x is equals to 16, right? And ds dt equals to 3. So we can write 20 times 3 equals to x is 16 times dx dt, correct? And that gives us dx dt as equal to 20 times 3. So I'm just writing 20 times 3 divided by 16. And that is equal to, we'll check the sign also, I'll get to that part. 20 times 3 divided by 16 equals to 15 over 4. So let me write this as, in decimals, let's write 3.75. And the units will be meters per second. Meters per second. Now here there is one very important thing to understand, and that is, since the distance is decreasing, right? So the unit, we'll say it is approaching at this speed, right? So the answer, we'll write down the answer as, boat is approaching at the rate of 3.75 meters per second. Do you see that? Now, so that is what we should be doing. Normally what happens is, in such situations, since the things are decreasing, we take negative sign into consideration. Now when you sketch it, it is kind of easier to see and explain. So that really helps, instead of incorporating negative signs in your equations, right? So that's my suggestion. I hope it works with you. Thanks for watching. Feel free to post suggestions, your comments and questions. You can surely subscribe to my videos and share them with your friends. Thank you and all the best.